Hello friends and colleagues, and welcome back to the ladder tutorial series. I'm Nadav. In the last episode we brought in animations for Mixamo to our mannequin here, and in this episode we're going to hook them up to the animation blueprint of our character so we can start see it actually climbing as we go and walk on top of the ladder as we climb the ladder. So I can go inside my third-person animation blueprint. And if you're having difficulties finding it, you can just click on your character here, go to Edit Blueprint, open Blueprint Editor, click on the mesh, and then you have an anim class here. This is your animation blueprint, and you just click this icon, and you go, and it finds it in the folder, in the correct folder. So an animation blueprint is a special blueprint, a little bit advanced, and we are not going to go to all of the details on how it works exactly, but generally it's a blueprint that we can use to feed data inside and create functions and variables and everything that any other blueprint has. And also it has an animation graph, and if you don't see it, you can just click here on the anim graph, double click it, and you'll see you have another graph here that you can use to drive animations and create animations and blend them. And one of the features inside an animation graph is a state machine. If you see, we have like a default state machine here. I can double click it. And this is how our state machine looks like. So what it does, it actually is a set of states of animations that only if certain conditions are met, these conditions here that we are creating, the animation will start. Okay, so it's a little bit advanced. It's not that complicated. Just if you're seeing this for the first time, it might look a little bit daunting, but don't worry so much. As you can see here, we have a very simple flow that is default with this project. We have an idle run animation that if a certain condition is met, in this instance is in air, condition is met, it starts the jumping animation, goes through it with through other conditions, and in the end it just checks again if this animation ended, this is this condition, and then it goes back to the walking animation, and we have a jump animation using this state machine. And we are going to add a new state here, which is going to be the climbing state. So let's start doing that. I'm going to right click here and go to add state, and I'm creating a climbing state. And inside I just click this, if I double click this, I go inside the animation editor here, and this is actually brings the output of this node, brings out the animation, the final animation pose of the animation I'm going to work through with here. And the animation we want to use is the climbing animation that we retargeted. So I'm going to right click and say play, just type climbing ladder anim Mixamo. Right? This is the animation that we want to play. And we can just hook it up for now here. So this is just playing the animation and giving the final result pose, if we are in this state, of course. And now we need to create the conditions. So we are going to ask, if you remember, in our third-person character, we have a is climbing condition that we turn this on, this boolean on, whenever we are climbing, and we're turning this off when we are stop climbing, right, in our toggle climbing function here. So what I want to do, I want to drive this boolean, I want to drive this state into our animation blueprint. I want our animation blueprint to also know if we are climbing or not, so it can go inside an animation climbing animation. So let's create a new variable here, the same name, it's a boolean, and we're going to call it also is climbing. Let's give it a question mark just to stay consistent here with the naming, but it doesn't matter. And now in order to use the conditions, all I need to do is just drag through here. You see this arrow formed, and just connect it to the state that I want the condition to run to. And then I have a new condition. I can just double click it, and you see it's just a boolean condition, and it asks a question, can enter a transition, and we're going to feed in is climbing. So if is climbing is on, okay, it's going to enter the climbing animation. And we need an outgoing condition to go back to walking. And again, we're just going to drag is climbing, but now we're going to tell it not. So if it's not climbing, so if this is turned off, we can go back to walking animation, back here to the walking animation. Okay, so this is set. It's very basic now. We're going to work on this more, of course. But the second thing we need to do is connect to bring this climbing boolean information through our third-person character. So our character has this animation, has this information, has the is climbing. We just need to feed it through. So in order to do that, we need to, of course, because this is this is not a default variable, this is a variable we created, especially inside our character here. We need to use casting in order to get this specific blueprint, as we did before. Okay, so in our third-person animation blueprint, we're gonna create a new event. It's called event blueprint initialize animation. Okay, this event is fired when the animation is initialized, and here we just want to cast. So we want to get. We can do this with get player pawn, or we can do this with get owner, also, which is better. Get owning actor, because we know that the owner of this animation is always our third-person character, right? It owns this animation through this mesh. You see anim class here, so we know this character owns this animation. So by getting the owner, we're actually getting the third-person character. But this returns here an actor value, and we need to be specific when we tell the system that this actor is actually a third-person character. So we want to use casting. So we type through here cast to third-person character. Connect this here, and now that we have our third-person character, we know we can check this by just dragging off here, and we can get is climbing. You see, we have it. But I want to save this as a variable first, because we might use this reference again and again and again. So I'm just going to drag out over here and say promote to variable. And I'm going to call this variable player con ref. So this is going to be the reference to our third-person character here that we are creating, we are customly creating. And everything here we're creating, we can access through the third-person animation blueprint, because we have this reference here saved. So now you see here, there's another node already set, which says event blueprint update animation. So this node is fired in every tick, every frame that the animation is being played, this is fired. And if you can see here, this is default, this we get with the project. What it's doing now is setting its own variable of Boolean, which is in air. It checks if the character is in the air. And also it sets the speed, it checks the speed of the character, so it knows how to drive the walking animation. So we're gonna just add here a new set, and we're gonna set our new Boolean is climbing, which we just created, and we're gonna get our player pawn ref that we just saved as a reference, and we're gonna get is climbing Boolean from it. So now we are accessing the third-person character actually here that we saved in the memory. We're accessing this blueprint through our animation blueprint, and we're just gonna set it. So what are we doing now? We are just setting every frame that this animation is played. Every frame we are checking if is climbing is on, and we are setting it inside our animation blueprint on our own Boolean that we created inside the animation blueprint. And in our state machine, going back to our state machine, now we are checking this state is climbing inside our animation blueprint each frame, and this information is coming from our third person each frame. And right now, we can already see it work, I think, if we hit play. Okay, so you see it is climbing. Okay, we have this weird effect that it jumps to a weird place in space that we don't expect. And we're going to fix that. But you see it is changing to climbing and back to walking as we are leaving the ladder. So let's fix that problem that we have with the animation. The problem that we are having is because we did a hacky way of doing the animation. We brought it out of Mixamo and retargeted, and we didn't do like a special animation, and it's a different rig. We're having some problems with the retargeting, and as you can see, if I drag the animation to the world, you see the pivot of the animation is actually not where we want it to be. We want the pivot of the animation to be here at the pelvis of our character to be centered. This is where we want it to be. But we can fix it really easily inside our animation blueprint. If we go back to our state machine here and back to our animation, the climbing animation, and we double click this, now we can start and mold. So this is the normal raw animation of the climbing. And now we can, through this pose that's output every frame, the correct pose, we can now change this pose to something else with a few nodes. So the first node I'm going to use is a modify node, and it's going to modify the bones here. We're only going to modify one bone, which is the root bone, because if you look at our character and the animation, you'll see we have a root bone, which is here, but we actually want to take the pelvis bone which all the other bones are inheriting from. So moving the pelvis will move everything, right? We want to take the pelvis bone and we want to center it here. That's what we want to do. We want to make sure that the pelvis is centered, and then it will center everything else. So I go back to the animation blueprint, and here I'm going to type local to component, and now we change the transformation to component, and we now can drag out of this a modify bone, which transforms a bone, and we are looking for the pelvis bone, right? We want to transform the pelvis bone. So clicking here on this node, you'll see on the right here, and this is a lot of the work with nodes in animation blueprint work is here on the right. But you see here, I need to first choose which bone I want to modify, and I'm going to choose the pelvis. And hit compile, and I can connect this to the output result. Okay, and you see here it says we have a warning. No command to modify selected. Okay, so let me show you. So on the right here we can control the translation, the rotation, and the scale. Right? We want to change. We don't care about the scale, and everything here is set to ignore. But we're going to start only with the translation. So let's first go to the translation. This will be the position on the world of the bone that we want to change, and we're going to change here from translation or from ignore. We actually wanted to start influencing this bone, so we can do either add to existing or replace existing. So let's do replace. And hit compile, and as we do that, we suddenly see a pivot here, which represents how this node is going to transform. So I can move this actually, and so let's first play our animation, because we are looking now at our climbing state, right? This is the climbing state that we are working on, and we can actually, here on the right, you'll see under our preview editor, if you don't see this, we can hit. If you don't need it, just click on the anim preview editor, and you can see we can turn on this condition is climbing just for the testing purposes. So if we hit this, we see the problem here with our animation, but now it's already better because it's replacing. So let's say I just disconnect this transformation node just for you to see what was before the problem, and of course we need to compile this before we can see the results. You see the problems here in the preview. That's the problem that we had, right? That we want to fix, and we are connecting this node that's going to modify, and we're now just modifying the translation, and we are zeroing it out. It's zero on every axis. So if we hit compile and see is climbing again, now it's zeroed, but we don't want it to be zeroed. We want it to be centered here. So we can actually just move this really easily, just raise it a little bit. Okay, hit compile, so we see the results. It gave us 83 on the z-axis. Let's round it to 85. Hit compile, and now when we do is climbing, we see it sets the climbing to the same position of the walking or the idle animation that we previously had. But we still have a problem that it's turning. So let's also change the rotation. Okay, so I'm just going to go here over to the rotation, and I'm going to change the rotation mode to add to existing, not replacing, but we're adding the rotation. And once again, I can click here the is climbing, and notice that I'm hitting compile every time I change anything here, so we can see it playing. But you see, we want to turn this character back 180 negative on the z-axis, right? So I'm just gonna, as I play the animation, I'm gonna just go to rotation. I hit the E key for shortcut, and I'm just rotating it 180 degrees. Hit compile, of course, and now we can see that our climbing is set correctly. We have our values here. And we can actually get rid of the scale, so we know we're not influencing it through here. We can just turn this eye off. It's just for visual flair. You don't need to do that. It just removes the expose here of the node. Now let's go back to our game. Let's hit play. Nice. And now the character is behaving correctly. The animation is behaving correctly. But we still have one problem, that the animation is continuously playing, and we want it to play only when we are climbing and stop playing when playing when we're not climbing. So to do that, it's really easy fix. We are just going to click here on our play climbing animation. Okay, this is the animation of the climbing itself. And here on the right, you see we can expose the play rate of the animation. So just need to click here on the little eye, and now we can plug in the play rate of the animation with a different variable. And what we can do now is actually create a variable that holds the speed of the climbing. Okay, we already have here a speed of the walking. This is a default variable that we got with the blueprint, but we're going to create here a new variable which is going to hold the climbing speed. And you see the play rate is from 0 to 1, and we need to take the speed of our player and normalize it from whatever values it has to a 0 to 1 value, so we can plug it in here. Okay, so that is exactly what we're going to do now. Let's go back to our event graph, and I want to create a new function and a new variable. So let's start with the variable. We're going to hit a new variable here. We'll go to float, and we're going to add a climbing speed variable. Okay, and next thing, we're going to add a new function, and this function is going to calculate and normalize the speed of the climbing from the speed that we are plugging in into a normalized value between 0 and 1. So let's call this function normalize climb speed. And we are going to use a normalize float, normalize to range. Normalize to range, this just takes a value, sees where it is between a minimum and maximum that we give it, and returns where it's supposed to be on that range from 0 to 1. Okay, so the minimum is of course 0. So because when we're not climbing, the climb speed is going to be 0. But what is the maximum? What is the maximum climbing speed? So in order to do that, we're just going to grab our player pawn again that we saved before, and we're going to type here get max speed, and this returns the maximum speed of the current movement mode. In our case, when we are climbing, we are in flying movement mode, if you remember before. And now we can go to, of course, to our character movement here, back to our character, and if we go down here, we have somewhere here flying. So here we have the maximum fly speed. So this will bring in this number here, and because we are doing it like this, whenever we are changing this number later in the future, because we are tweaking this value for some reason, we don't need to replug it in here. It's gonna dynamically update. So we're just gonna get the maximum speed and plug it to the range max. And now we need to get the current speed just to see where it's at between those two values, between the min and the max, right? So we're gonna get our player pawn again, and we're gonna get its velocity, and we're gonna get the velocity length, the vector length, get vector, vector length. This will give us the velocity. We connect it to the value. Okay, and now we just need to add an output to our function that returns that value that we just normalized. So let's hit output here. It's going to be a float. We connect this. We connect our calculation on a normalized node to the end result. And let's give this a name, normalized climb speed. And we can, so now if we go back to our event graph, we can just set the climb speed, and I'm just holding Alt, set the climb speed, and then we can call our function. But you see, when I bring the function in, I need to connect it like that to the event graph. But actually we can make this simpler for us. We can just go to the function again, and by clicking it, and then we can go here and click the pure and compile, and then the function doesn't need to be connected to the event. It can be just connected here to the final set result. Okay, let's see if this works. Oh, sorry, and of course I forgot to connect this variable that I just created, the climbing speed, into our play animation, the climbing animation, the play rate. Okay, let's connect it, the climbing speed, and play again. Okay, and you see when I'm not climbing, it's not doing anything, and when I'm climbing, it's playing the animation. One last thing is that we want the animation to play in reverse when we are going down. Now it looks a little bit weird, so we want to change the animation to play in reverse when we go down. Okay, so let's do that. Going back to my normalized climb speed, I'm just gonna add a new check here. So we are getting the velocity of the character, right? And we can actually, out of it, break this information, and we're just getting the z-axis because we are only moving the character on the z-axis, and we now can check, is this number smaller than 0? So it's negative, right? And if it's true, if it's false, we're doing the same thing. And we forgot to, and we need to connect, of course, the branch here. So our function is checking if the vector, the velocity, is negative. If it's not negative, return the normalized range. If it is negative, we want to take this normalized range and multiply it by -1, because we want to play rate -1. Okay, we want to play the animation in negative values, from 0 to -1. And now we just need to create a new return node that is going to return the second value, the negative value, to our to return it through our function. Okay, so if it's true, if it's negative, we're going to return this value, the normalized values, times -1, and if it's positive, we're just going to return the normal value that we had, which is positive value. Let's check this again. Going up, going down. Now it looks much better. Okay, you see that it's not perfectly aiming at the ladder rungs, but it's good enough for what we're doing in this tutorial. And already we have a character that is walking up and down the ladder, animating, and it gets off the ladder and all that stuff. And the ladder is, of course, procedurally generated, so we can decide on this, how big it is, whatever we'd like. Nice. Okay, that's it for this episode. Next episode, we'll try and give ourselves the ability to jump off the ladder and maybe hold on a different ladder. By the way, it works. You can jump from the ground and hold the ladder, but we're gonna give the actor the player the ability to jump off a ladder, which is not possible right now. And I hope to see you in the next episode, and don't forget to subscribe to the channel to stay updated. See you later and happy deving!